Let's talk about laws of thermodynamics. There are basically four laws in thermodynamics: zeroth law, first law, second law, and third law. So let me tell you of the first law, which is the zeroth law of thermodynamics. Now, what is this law? This law talks about thermal equilibrium, and it also helps us in measuring temperature. And how do we measure temperature? We measure temperature on the basis of this concept, that is thermal equilibrium. What is this concept? This concept is simple, that if there are two bodies and they are in contact with each other, then after some time, if they have some temperature difference, then they'll have the same temperature after some time, and that moment when they'll have same temperature, that is the exact moment when they are in equilibrium. And that equilibrium, when they have when they both have same temperature, is thermal equilibrium. So zeroth law is something which helps us in measuring temperature. And how do we measure temperature? With the application of thermal equilibrium. And also there is one more thing, that what this law is. What is it? See, whenever there are two bodies that are separately in thermal equilibrium with the third body, then these two bodies will be in thermal equilibrium with each other. This is the simple statement of zeroth law. Now coming to the first law. First law is the law of energy. It talks about conservation of energy, that energy can neither be created nor be destroyed, and it can be converted from one form to another. And also this first law talks about that if heat given to the system or the gas could be utilized into raising its internal energy and also performing some work if the system is made to do so. So this is the first law. Now coming to the second law, we are just discussing the introductory part of these law. We'll discuss these law in detail also. Now what is the second law? Second law basically talks about entropy. And second law, it is a directional law, and it talks about how the energy flows and whether the energy flow is possible, or the feasibility of a system, whether it exists or not. And also the second law is a law of entropy, in which there are two statements we have. One is the Clausius and another is the Kelvin-Planck statement. We'll be discussing these statements later in detail, but right now we can just see the basic statements. What are they? What do they say? See, the basic the first statement we can take is the Clausius statement. What does it say? Clausius says that heat cannot be flown from low temperature reservoir to high temperature reservoir, and if it flows, it can flow only by the addition of some external agency. If we add some external agency to the system, then only it is possible. And what we have is the other statement, which is the Kelvin statement. It is for engine. It says that it is impossible to construct a device whose sole purpose is to convert all the heat given to it into mechanical energy. That means complete heat conversion or complete heat cannot be converted into work, mechanical work. Why? Because if it happens, then the engine I'll be having will have 100% efficiency, and that is impossible. It is not practical. These two law talks about the impossibility of the system, or one could say the possibility of the system. If we know how we cannot make the system, then of course we have opened the doors for designing the system on the basis of its possibility. The final law we have is the third law. It talks about that the entropy of a perfectly crystalline body is 0 at 0 Kelvin, and also that 0 Kelvin does not exist.